Hello everyone, in this video I am going to explain previous year NEET questions. So in that question 1, previous year NEET questions from reaction mechanism 1 chapter only. In my previous video I explained what in this chapter reaction mechanism, from reaction mechanism previous NEET questions only. Okay, right. Consider the following species. And I will explain APSET questions also. I mean MSET, TS MSET questions also. So consider the following species. The number of species which obey Haeckel rule is. So here 7 species given. In those 7 species, how many of they follow Haeckel rule? So first, what is the Haeckel rule? Haeckel rule means Haeckel rule. It is following Haeckel rule means first that is cyclic and planar, all sp2 carbon, conjugative system, and the last rule that is important, 4n plus 2 number of 4n plus 2 delocalized pi electron. Delocalized pi electron. Here, see, this is conjugative single bond, double bond, single bond, double bond, single bond, double bond, single bond, double bond. Conjugative system. How many pi electrons here? Each pi bond contain 2 pi electron. Here 5 pi bonds contain 10 electron. 10 is Haeckel number or not? Yes, 10 is Haeckel number. If you take 2, n is equal to 2. N is equal to 2 means 4 into 2 plus 2. You can take any number, all those numbers are Haeckel number. For example, if you take n is equal to 1, n is equal to 0. N is equal to 0, 4 of 0 plus 2 is Haeckel number. And here what? If n is small n is equal to 1, 4 1s are 4 plus 2, 6. If n small n is equal to 2, 4 2 is 8 plus 2, 10. And if small n is equal to 3, 4 3 is 12 plus 2, 14. These are Haeckel number of electron. So here 10 is Haeckel number. Okay, that's why this is following Haeckel rule. It is following Haeckel rule. Here these pi electrons involved in delocalization. These pi electrons involved here in delocalization. Total number of pi electrons become 6. 6 is Haeckel number or not? Yes, 6 is Haeckel number. Clear. Here 4 pi electron. This is not obeying law. Haeckel rule, it is not following Haeckel rule. So this is not. So this one okay, this one okay, and this is not following Haeckel rule. So here 2 plus like this, 2 plus 2, 4 electron. 4 electron mean it is not following Haeckel number. So here 2 electron means following Haeckel number. Okay. So here pi bond shift takes place like this. Next here 1 2 3 4, 4 to the 8 electron. 8 is not a Haeckel number, anti-aromatic compound, not aromatic, not Haeckel rule. It is not following Haeckel rule. Not okay. Here 1 2 3 4 5 6 7, conjugative system, 7 to the 14 electron. 14 is Haeckel number or not? Yes, 14 is Haeckel number. That's why how many? 1 2, here 3, this is 4. Answer is D. That means 4 species in the given following Haeckel rule. Okay, take this one. Next, see this next question. Which compound amongst the following is not an aromatic compound? Which is not aromatic? Which is not aromatic? So which is not aromatic? See here, not aromatic means that is not following Haeckel rule. So if you see here, here how many pi electrons are delocalizing? Conjugative system, double bond, single bond, positive charge. Positive charge, single bond, double bond, single bond, double bond. Conjugative system, okay. All sp2 carbon, okay. So all are okay. So here, if you see here, total number of pi electrons are 3 pi bond means 6 pi electron. 6 pi electron means this is what? Aromatic. 6 pi electron means this is aromatic. Here, how many pi electrons? 2 pi electrons in delocalization. Double bond, single bond, positive charge, single bond, double bond. Conjugation and only 2 pi electron. 2 pi electrons in conjugation means this is also aromatic. 2 pi electrons in conjugation. Here how many pi electrons? 6 pi electrons in conjugation. 6 pi electron. If you see here, this is what? This is sp3 carbon. sp3 carbon means not aromatic. Non-aromatic. This is what? Non-aromatic compound. Here how many pi electrons? This like this. How many pi electrons here? 6 pi electron. 6 pi electron. That's why this is also aromatic. Therefore, what is answer? This is not aromatic. Okay. Aromaticity is important for NEET question. Take this one. Next, see the next question. Given below are two statements. Acidic strength of monosubstituted nitrophenol is higher than. In statement 1, acidic strength of monosubstituted nitrophenol. That may be anything. Nitro means at any position one nitro group. Phenol, in statement 1, acidic strength compared between phenol and nitrophenol. So, and statement 1 is acidic strength of monosubstituted nitrophenol is higher than phenol because electron withdrawing nature of nitro group. This is correct statement because nitro group is what? Electron withdrawing group. Electron withdrawing group stabilizes the conjugate base of phenol, phenoxide ion. So after loss of H plus ion, what is formed here? O minus. O minus, the negative charge species. Negative charged species are stabilized by minus M groups. That's why its conjugate base phenoxide ion is more stable. That's why it is more acidic. That means statement A is correct. So acidic strength of phenols or any acid explained on the basis of stability of their conjugate bases anions. Those anions are stabilized by minus M groups, electron withdrawing groups. Due to presence of nitro group, electron withdrawing group, this phenol is strong acid, or nitrophenol is strong acid than phenol. Statement 1 is correct. Next, statement 2 is orthonitrophenol, metanitrophenol, paranitrophenol will have same acidic strength as they have one nitro group attached to phenolic ring. Orthonitrophenol, paranitrophenol and orthonitrophenol, this is orthonitrophenol, metanitrophenol, orthonitrophenol and metanitrophenol and paranitrophenol will have same acidic strength because all those have one nitro group. That statement is wrong because so minus M group definitely minus M effect. Minus M effect increases acidic strength, but minus M effect at meta position, ortho position, para position are not same. Minus M effect at this position is weak. Minus M effect at meta position is weak. That's why this is less acidic. Between orthonitrophenol and paranitrophenol, in orthonitrophenol due to formation of intermolecular hydrogen bonding, orthonitrophenol less acidic than paranitrophenol. Here 2 points. First of all, these three are not same acidic because nitro group minus M effect, that electron withdrawing effect of nitro group at 3 positions not same. At meta position minus M effect is negligible, very low. Point number 1. That's why this is very less acidic between these among these three. So between orthonitro and paranitro, in orthonitrophenol hydrogen involved in intramolecular hydrogen bonding. That's why orthonitrophenol less acidic than para. That's why which is more acidic? Paranitrophenol stronger acid than orthonitrophenol strong acid than metanitro. That means these three are not same acidic. Statement 2, all those have same acidic strength. but that is wrong. Statement 1 is correct, statement 2 is incorrect. So option B is correct here. Okay. So in my videos I have explained very clearly about this concept. Okay, take this one. Next, see this next question. What? Tertiary butyl carbocation is more stable than secondary butyl carbocation. What is the tertiary butyl carbocation first? This is tertiary butyl carbocation, which is more stable than secondary butyl carbocation. Of course, that statement is correct. But why? Secondary carbo, because of resonance effect of CH3 group do not cause resonance effect. The concept of resonance effect is wrong in both. Next, hyperconjugation, inductive effect. Hyperconjugation and minus I effect. Hyperconjugation correct, inductive effect is also correct, but methyl groups show plus I effect, not minus I effect. So therefore, first of all, statement 1, 2 are wrong because methyl groups do not cause any resonance effect. Next here, minus I effect. This is also wrong. Of course, methyl groups show I effect but not minus I, that is plus I. So which statement is correct? Hyperconjugation. Of course, these 3 are what? Alpha hydrogen. How many alpha hydrogen? 9 alpha hydrogen. More hyperconjugation. Here, how many alpha hydrogen? 3 plus 2, 5 alpha hydrogen. Less hyperconjugation. In that sense, tertiary carbocation is more stable than secondary carbocation. Okay, take this one. Right, see this question. Which of the following is correct with respect to minus I effect? With respect to minus I effect of the following. So minus I effect order of minus I effect, minus I groups and their order, plus I groups and their order I have given in my videos. So based on that sense, fluorine halogen highest, fluorine is highest. Minus I effect for fluorine is greater when compared to OR. Of course, this is also greater when compared to NH2. So this statement is correct. Of course, B also correct. NR2 also less minus I effect compared to OR and F. That's why both are correct. B and C both are correct here. Take this one. Next, see this question. Which one is the most acidic compound? Which one is the most acidic compound? Phenol, nitrophenol, 2,4,6 trinitrophenol and 4-methyl phenol. Between these three, so what about this one, methyl group? Methyl group is what? Methyl group is plus I group. It causes plus I and positive hyperconjugation effect. So both are unfavorable for acidic strength of phenol, because so phenol acidic strength is promoted by minus R groups, minus M groups, minus M groups, minus I groups. So minus I and minus M groups stabilizes these groups stabilizes conjugate bases. What are conjugate bases? Anions. And increases acidic strength of corresponding acids. Increases acidic strength. So wherever minus M or minus I groups come, minus M group comes, then acidic strength increases. But this is plus I plus H effect, unfavorable effect. This is minus M effect, strong minus M effect, 3 positions, 3 minus M effects very strong acid, most favorable, because minus M group is increases acidic strength of phenol. Here only one minus M group, here neutral. Here nothing is there means neutral. That means which one is due to presence of 3 minus M groups, this has more. So first acidic strength we can write its order also. The stronger acid is C. After C we have B. So after B this is negative effect. Negative means unfavorable effect for acidic strength of phenol. Minus I effect is unfavorable effect. Here neutral. Neutral better than unfavorable effect. So A, then what? Last D. So this is the order. In this way we solve questions. So these are questions, previous NEET questions from reaction mechanism 1. Next, previous year MSET questions. First take this one. These are 2023 MSET questions. Okay. Which of the following? In which of the following hyperconjugation is not possible? So in our videos, hyperconjugation, a separate video where I have explained hyperconjugation is possible in these cases whenever alpha hydrogen, sigma electron. So to this is what? Alpha carbon. To that this is what? Alpha carbon. This is alpha carbon. So alpha carbon, these are sigma electron. Alpha carbon, sigma electron shifted here, then this bond shifted here. Thus it become, here what we get? Negative charge here, a double bond, and here what? C, here hydrogen positive, like this. The delocalization of alpha carbon, sigma electron, hyperconjugation is possible. So this hyperconjugation is not possible if alpha hydrogens are not there. Here no alpha hydrogen, no hyperconjugation. In A option, no alpha hydrogen, no hyperconjugation. So this is correct answer. In which of the following hyperconjugation is not possible? In A, not possible. Here, so how many alpha carbon? Only one alpha carbon, one alpha hydrogen. One alpha hydrogen is there. Here, this is alpha carbon, two alpha hydrogens are there. This is alpha carbon, two alpha hydrogens are there. This is alpha. Next carbon is beta, next hydrogens are beta hydrogen. Hydrogens of this carbon, beta hydrogen, hydrogens of this carbon, alpha hydrogen. Thus option A is correct. Take this one. Next, the delocalization of sigma electrons of CH bond and sigma electrons of CH bond of an alkyl group with pi electrons of benzene. Just now we have discussed pi electrons of benzene and sigma electrons of CH bond. Sigma electrons of CH bond delocalization. Just now we have discussed. Okay, due to shift of electron, sigma electrons of CH bond, this bond shifted here, then this become minus. This is called as hyperconjugation. So which option correct? Hyperconjugation effect. This is called as hyperconjugation effect. Take this one. See this question, the aromatic species with maximum number of pi electron. So to answer this question, we must know these names, the structures of these common names. So all these are common names. Phenanthracene. What is phenanthracene? Not common name. This is basic name only. This is phenanthracene. This is what? This is what phenanthracene is. It as IUPAC name only. Phenanthracene is IUPAC. Phenanthracene has how many pi electron? 1, 2, 3, 4, 5, 6, 7. 7 to the 14 pi electrons. Aromatic. Aromatic or not? Yes, this is aromatic. 14 is alkyl number. All sp2 carbon delocalization. Next one, naphthalene. Naphthalene has 2 benzene fused rings. Anthracene has 3. So 1, 2, 3, 4, 5. 5 to the 10 electron. 10 pi electron. This is what? Naphthalene. Naphthalene, how many? 10 pi electron. 10 pi electrons in delocalization. So this is also alkyl number. So aromatic. Third one, cyclopentadienyl. Penta means 5. Cyclopentadienyl. Diene, 2 times double bond. Anion, negative charge. So total number of, this is what? Cyclopentadienyl. Cyclo because cyclic, penta because 5 carbon. Diene, 2 double bonds. Diene, 2 double bond. Dienyl cation. Dienyl cation. How many electrons? 6 pi electron. 6 is also alkyl number. So this is also what? Aromatic. And when you comes to cyclohepta, hepta means 7 carbon atom. Hepta means 7 carbon atom. Cyclohepta, 3 times enyl cation, positive charge. Okay, cyclohepta, trienyl cation. It has 1, 2, 3, 4, 6, 5 electron. This is also aromatic. All are aromatic only, but maximum number of pi electron. 14 is maximum number. So which option is correct? Phenanthracene is correct. Okay, take this one. Next, see this question. Arrange the following in the correct order of their acidic strength. If you see ethylene, to say acidic strength, first remove one hydrogen, then rest become minus, conjugate base. What is the conjugate base of acetylene? This is acetylene 2. And conjugate base of propane, this carbon with negative charge, that is 3. And here remove hydrogen from one carbon, that is CH2 minus, this is 4. Now, in which, in the above, which is strong acid? If its conjugate base is more stable, that is strong acid. Conjugate base of this one is this. Conjugate base of 2, conjugate base of 3, conjugate base of 4. Which acid is strong acid? Whose conjugate base is more stable is strong acid. Now we have to say the stability order of conjugate bases, then it is possible to predict the strength, acidic strength order. So this is what? This is sp2 carbon. See, sp2 carbon. So this is what? This is sp carbon. And this is what? This is also sp carbon. Here this is what? This is sp3 carbon. So remember one thing, if negative charge in delocalization, that is sp2. If negative charge not in delocalization, that is sp. Whenever negative charge is present in delocalization, that is sp. If very, very important point we have to remember. If negative charge involved in delocalization, then carbon ion contain which hybridization? sp2. If negative charge not involved in delocalization, then carbon ion hybridization sp3. So this is very, very important. Okay, right. Here this is negative charge which do not involved in hybridization, do not involved sp3. Okay, so sp carbon with negative charge more stable. sp carbon more electronegative, electronegativity order. sp carbon more electronegative than sp2 carbon, which is more electronegative than sp3 carbon. More electronegative species with negative charge more stable. So remember, sp carbon with negative charge more stable compared to sp2 carbon with negative charge. sp2 carbon with negative charge is more stable when compared to sp3 carbon with negative charge based on their electronegativities. So that's why these two are more stable when compared to this one. This is more stable when compared to this one. If you compare these two, here what this is plus I group. Plus I group destabilizes anion. Plus I group destabilizes anion. That means this is first. So which one is more stronger acid? 2 is stronger acid. This is more stable. This is stronger. After that 3. After that 3. After that 1. After that. So which is correct? 4th is correct. We have to remember 2 points. 1. sp carbon with negative charge more stable. Corresponding acid is strong acid. Between 2 sp carbon. So here minus I effect is here. So minus I effect decreases stability of carbon ion. Whenever carbon ion is unstable, conjugate base is unstable, its acid is weak acid when compared to this one. So take this one. Next, see this question. The correct order of stability of following compounds based on hyperconjugation. Based on hyperconjugation, which one is more stable? See here, this is double bonded carbon. To this double bonded carbon, adjacent carbon is alpha. To this double bonded carbon, there is no alpha carbon. How many alpha hydrogens are there? 3 bonds means only 1 alpha hydrogen. Only 1 alpha hydrogen. Here, this is alpha carbon, adjacent carbon to double bond. This is also alpha carbon. 2 bonds means 2 hydrogens here, 2 hydrogens here. Total 4 alpha hydrogens here. Here, 2 double bonded carbon, this is alpha carbon, 2 double bonded, this is alpha, 2 double bonded carbon, this is alpha. 2 plus 2 plus 3. Total 7 alpha hydrogen. If you see here, to this double bonded carbon, this is alpha, to this double bonded carbon, adjacent alpha, this is adjacent alpha, this is adjacent alpha, 2 plus 2, 4, 3 plus 3, 6. Total 10 alpha hydrogen. With more number of alpha hydrogen, more the number of alpha hydrogen, more will be hyperconjugation effect and more will be stability. So which one is more stable on that sense? With 10, 4 is more stable. In all options, 4 is given. Next 3. Okay. Next 2. Next 1. So which option is correct? This is correct. Okay. So with blue pen is my explanation. Only black is the question. Okay. So take this one.